Okay, so I finally received these Jugee batteries from the United States, and the reason why I had to get these stateside is these are very difficult to find, even though these are Chinese made. There is another brand actually that does the same thing and has the same capacity, and I can't remember what it's called, but anyway, based on my research, it seems that Jugee is the original manufacturer of these, and they own the patent. The other one might be called Kent Lee or something along those lines. So have a go searching for them. They are quite costly, and there are only a few sellers stateside that carry this. So I had to wait a couple of weeks for this to arrive. But that being said, they are now here. So this might be the next revolution in AA and AAA batteries. So these are actually lithium secondary batteries. So for many years we've had lithium primary AA and AAA batteries. So they put out 1.5 volts. This one here, these are actually secondary batteries, so they are rechargeable, and they put out 1.5 volts. Now I know you can't see that on this camera because it's probably won't focus well, but I'll just talk through it. I was going to say, what's worrying is, oops, these batteries actually came already open, unsealed. So I hope they haven't sent me a used one, but there we go. As I said earlier, I haven't got much of a choice anyway. So back to these batteries. So these are lithium cells, and they put out 1.5 volts, and they're rechargeable. So the advantage of using lithium over nickel metal hydride is obviously they have a longer shelf life, lower self-discharge, and they are a lot lighter. They weigh a fraction of what nickel cells would weigh. But let's talk about the disadvantages of this. So first of all, as I mentioned, they're very hard to source at the moment, but that might change in the future if demand grows. The other disadvantage that I know you probably can't see, but this is rated at 3000 milliwatt hour. So if you take 3000 and divide that by 1.5, that gives you 2000. So you get 2000 milliamp hours worth of capacity in a AA battery, whereas you could get way more than that. You could get maybe 3000 in out of nickel metal hydride cells. So immediately you're only getting 2/3 of the capacity. And of course the other disadvantage, as I mentioned earlier, is these are very costly and very hard to find. So anyway, let's talk about the advantages now. So as I mentioned earlier, these put out 1.5 volts instead of 1.2, which make them a lot more compatible with applications that don't allow the use of rechargeable batteries, for example. So just to give you a very quick example, if you are building a receiver pack for a nitro RC vehicle, for example, so you would know that servos run at 6 volts, for example. So to power that system, you would either need to use 5 secondary batteries, or if you were using primary batteries rated 1.5 volts, then you could get away with using just 4 of them. So with these secondary ones putting out 1.5 volts, you could use just 4 instead of 5. And of course, as I mentioned earlier, they're a lot lighter than nickel based batteries. But anyway, let's get into the technical details of how this works. So incredibly, they've actually crammed in. So the way it works is, because you may be wondering, you may be thinking lithium batteries have a nominal voltage of 3.2 volts. So how do they get this down to 1.5? So the answer to that is there is they've managed to cram in a tiny circular PCB right at the top of it. So this is actually what it is this is a cylindrical lithium cell internally that does put out about 3.2 volts. But on top of of that, they've crammed in a tiny circular circuit board that is performs a buck, so buck function in both directions. So what it does is, when the battery puts out the voltage, the circuit board actually regulates that down to 1.5 volts. It's got a built-in inductor and a feedback loop and stuff like that, and it's got an IC that controls all that, and it makes sure that the output stays at 1.5 volts at all times. And the other disadvantage of using all these batteries is you have to charge them using 5 volts. So it says here 5 volts in, and on the back of this pack it does say in Chinese the minimum charging voltage is 5 volts and the maximum is 5.5. So you can't use a standard charger to charge this because they only put out 1.2 volts. So again, what the PCB does is, when charging this, it acts as a buck mechanism for the reverse direction. So it takes 5 volts input and it bucks it down to about 3.5 volts, I suppose, to charge the lithium cell. So it bucks the voltage in both ways. And this ring here around the positive terminal is actually an LED ring that will light up to show you the status when they're being charged. So again, that's driven by the tiny PCB that they've managed to squeeze in there. I suppose charging this at 5 volts makes them compatible with USB chargers. So you can see here the charger that comes with it. This is just micro USB. So I'm sure this is a very dumb device that it doesn't do anything apart from routing the 5 volts from USB directly to the batteries, because USB outputs 5 volts anyway. So maybe that reduces the cost of making these chargers, but these batteries are incredibly expensive anyway to begin with. So there you go, you gain some and you lose some. I'm not sure what I'll be using this for, to be honest, but I felt that I had to get this so I can make a video for you guys on YouTube. This is obviously just a converter to adapt AAA to AA. And the AAA versions, the AAA version of these are only rated at 1000 milliwatt hour, so really low capacity for this. Still, many years ago, NIMH batteries were rated at even less capacities than this. So that's it really. Yep, nothing more to say. So I'm going to get these charged up and I'm going to measure the voltage and give them a go. Now, I'm still a bit disappointed that they came unsealed, because who knows whether these are actually unused or whether they've reached the end of their lives. I can't see any markings on the terminals, which is a good sign, but yeah, that's what we've got for now. Alright, cool, thanks for watching. Oh yes, I just remembered something I forgot to mention earlier. So this, because of the way this works, there is another disadvantage to using these batteries. So you would have remembered I mentioned that the batteries contain a circuit board that acts as a power supply unit, and the problem with that is it's going to maintain the battery's output at about 1.5 volts, all the way, and because it's a buck circuit, it can control the output regardless of the voltage of the lithium cell that's in it. So because of that, you're not going to be able to measure the remaining capacity of these batteries. I mean, not externally anyway, because the output voltage will always be 1.5 volts right until the very end, when it falls off the cliff and the circuit cuts off the power output of these batteries. So you could be using this in cameras thinking that you've got lots of juice left, and out of a sudden they just fall flat. So just keep that in mind when using these batteries. So that's it from me. Thanks for watching.